Have you ever felt like your AI assistant has the memory of a goldfish? You tell it something important and just minutes later, poof, it's gone. Well, what if we could actually teach an AI how to remember? There's a new framework called memory-R1 that's designed to do just that. And honestly, it might just change everything.
Yeah, we've all been there, right? You tell your chatbot something and 5 minutes later, it feels like you're talking to a complete stranger again. So what's the deal? Why are they so bad at remembering things? Well, the core of the problem is, actually, it's surprisingly simple.
It's because most AIs are what we call stateless. Now that's just a fancy way of saying they have no memory of past conversations. Every single time you talk to it, it's a completely fresh start, a total blank slate. It's kind of like having a conversation with someone who just has no long-term memory.
To really get how big of a problem this is, the researchers behind memory-R1 came up with a perfect little story to illustrate it. Let's call it A Tale of Two Dogs.
Okay, so imagine this conversation. A user, let's call him Andrew, tells his AI he adopted a puppy named Buddy. Awesome! Sometime later, in a totally new chat, he mentions he adopted another dog, and this one's named Scout.
But this is where a standard AI just completely falls apart. You can see it right there in the middle column. The vanilla language model just gets confused. It sees the new name Scout and assumes Andrew is correcting the name of his dog. So what does it do? It overwrites its memory of Buddy. And just like that, the AI is convinced Andrew only has one dog, Scout. Buddy is completely forgotten.
This slide just shows you the flawed logic perfectly. The AI does this really clumsy delete and add operation. It literally deletes the memory of Buddy and adds a new one for Scout. Because it has zero memory of the context, it just can't grasp the idea of having two dogs. It just sees different names as a conflict that it needs to fix, not as new information to add.
Okay, so that's the problem. What's the solution? This is where we get to the really exciting part, the breakthrough, teaching an AI to actually learn how to remember.
The researchers call it memory-R1, and this quote from their paper is key. It's a reinforcement learning framework, which is basically a way of training an AI by rewarding it when it makes good decisions. This framework lets the AI actively manage its memory. And that's the crucial point here. It's not just storing data. It's learning how to organize it, almost like a person would. So let's go back to our two dogs, Buddy and Scout. With memory-R1 in charge, the outcome is completely different. The system hears another dog and correctly understands, oh, this is an addition, not a correction. It doesn't see a conflict at all. It sees new information that builds intelligently on the old. So instead of that clunky delete and add, memory-R1 performs a single smart update. It just combines the information. Andrew adopted two dogs named Buddy and Scout. Simple, accurate, and exactly what you'd hope a helpful assistant would do. This is so cool, right? But how does it actually work under the hood? Well, it all comes down to a team of two specialized memory agents.
Think of it like this. First up, you've got the memory manager. It's basically a super smart librarian. It looks at new information and learns whether it should add it, update something that's already there, delete something old, or maybe just do nothing at all. Then you have the answer agent. This is your expert researcher. When you ask a question, it sifts through all the memories and pulls out only what's relevant to give you the best possible answer.
And this two-stage pipeline shows how it all fits together. First, in stage 1, that memory manager is always on the job, listening to your conversations and building up the memory bank, adding, updating, and refining things. Then, when you ask a question, stage 2 kicks in. The system grabs any relevant memories, and the expert answer agent boils them down to only what's needed, generating a clear, accurate answer. It's a really beautiful two-step process.
An elegant system is great and all, but does it actually work? Well, the researchers put memory-R1 through its paces on something called Locomo, which is a really tough benchmark designed specifically to test an AI's long-term conversational memory.
And the results? They are stunning. This chart shows a score on a metric called BLEU1. You can just think of it as a grade for accuracy, how close the AI's answer is to the perfect answer. Before this training, the base model scored around a 22. With memory-R1, that score jumps to over 37. That is a huge leap.
To put that jump into perspective, it is a 69% relative improvement. 69%. This isn't just some small tweak. It is a fundamental leap forward in how AI can handle and recall information over time.
Okay, so we've seen the problem, we've seen the solution, and we've seen the proof. So what's the big takeaway here? Why does any of this actually matter for you and me?
Well, the big idea here is a fundamental shift in how we think about AI memory. For it to really work, it can't just be pre-programmed. It has to be learned. And this research proves that using specialized agents, our librarian and our researcher, is way more effective for handling these complex memory tasks. But what's truly incredible is how efficiently it learns. These massive gains came from just 152 training examples. That's it. This isn't just an improvement, it's a huge step toward the kind of persistent, truly intelligent AI assistance we've all been waiting for.
And that really brings us to the final question. Just imagine an AI that actually remembers you, your preferences, your projects, your past conversations, your goals. What could you build with that? A personal tutor that remembers what you struggle with? A creative partner that knows your unique style? The possibilities are just endless. And thanks to frameworks like memory-R1, that future might be a whole lot closer than we think.